NASA can't explain what's happening on Neptune. To date, there has been only one expedition to Neptune, the Voyager 2 flyby in 1989. That flyby finished a grand tour of the outer planets that took use of a remarkable gravitational configuration to propel the spacecraft from Jupiter to Saturn to Uranus to Neptune. And there have been numerous questions unanswered about this planet even by NASA. What are the mysteries of Neptune? They are unanswerable by any. Let's check them out. Welcome to our channel, where you get real updates about space and technologies. In today's video, we are discussing what NASA can't explain what's happening on Neptune. Don't forget to hit the like and subscribe button and also smash the bell icon so that you can be notified when we release a new video. Kindly stay tuned to the end of this video to know mysteries about this planet. Thanks. Even though no mission to Neptune is presently being funded, a Uranus orbiter and probe envisioned in the Planetary Decadal Survey of 2013 to 2022 may be altered to investigate Neptune if Jupiter's current alignment were more favorable. NASA's Goddard Space Flight Center senior scientist Amy Simon told Space.com, "Until another ship can get out there, scientists must rely on ground-based telescopes such as Keck II and space-based observatories such as the Hubble Space Telescope and the Kepler Space Telescope to acquire infrequent sightings of Neptune in between their other duties. This leaves a lot of unsolved questions concerning the blue planet. Here are some of the top queries yet to be answered. Why is Neptune's magnetic field offset? Uranus and Neptune have approximately comparable size, composition, and location. Thus, astronomers assume the two planets have somewhat similar formation histories as well. Uranus and Neptune also both have off-kilter magnetic fields, which separates them from the bigger gas giants, Saturn and Jupiter. Specifically, if you were to overlay a magnet over these planets, the magnet would not line up with the center. We have no idea how you even do that," Simon remarked. Because magnetic fields are formed by moving currents, it is believed that all planets with magnetic fields, including Earth, contain conductive material moving in their centers. But because Neptune's magnetic field is slanted at 47 degrees to the planet's rotation, it's evident that rotation and magnetism are not necessarily linked. Neptune's magnetosphere endures extreme changes with each revolution due of this misalignment, NASA noted on a page about Neptune. What happened to the Great Dark Spot? Although Jupiter's Great Red Spot is its most recognized feature and the solar system's most powerful storm, its size has been steadily decreasing for decades for reasons that are yet unclear. When Voyager 2 flew by Neptune in 1989, scientists noticed a great dark spot on the planet's surface. In 1995, the new Hubble Space Telescope observed Neptune in great detail for the first time. However, by that time, the site had magically vanished. As far as scientists are concerned, they don't know exactly how it vanished off Neptune's surface, Simon added. Since Neptune's photo resolution is so low at this distance from the Earth, Hubble later discovered another possible dark spot. What is the interior of Neptune made of? Neptune's interior is a mystery to astronomers since they cannot peer inside the planet. Lunar and Planetary Institute's 2003 model proposes an atmosphere of hydrogen, methane, and helium, among other things. Lower yet are the levels of additional substances such as liquid hydrogen compounds, nitrogen, and oxygen, all of which can be found below the atmosphere. If there is a core, it will be composed of rocky and ice material. For a more accurate prediction of Neptune's internal composition, Simon said that data from other planets taken by NASA satellites will be used. One of Juno's primary goals upon arrival at Jupiter in July was to carry out this investigation. In addition, the Cassini probe will drop to Saturn's surface in 2017 and collect as much data as it can about the planet's atmosphere and innards before exploding. Temperature is a major issue. Don't forget to smash the like and subscribe button. Thanks. On Earth's surface, we can only detect temperatures in the uppermost layers, stated Michael Wong from Berkeley in an email. While Neptune is hotter than Uranus in terms of actual temperature, we find that the two planets are nearly identical. Because Neptune is further from the Sun, it should receive less solar illumination than other planets. This similarity in temperature indicates that Neptune is warmer in terms of how much heat it generates in comparison to the quantity of heat it absorbs from the Sun. As NASA's Goddard Institute for Space Studies, GISS, scientist Anthony Del Genio explained to All About Space, measurements from Voyager reveal Neptune produces more heat than it absorbs from the Sun. And it's at this point that things start to become interesting. As a result, Neptune isn't out of the ordinary here. Jupiter and Saturn likewise generate about twice as much heat as they absorb, but Uranus does not, Del Genio said. Uranus is an outlier, as one observer put it. Jupiter is the gas giant with the highest temperature, followed by Saturn and Neptune according to the trend of temperature as you move away from the Sun. Uranus is the one that doesn't fit in with the other planets, Del Genio commented. Uranus doesn't have a substantial internal heat source, hence that unique outcome is linked to that fact. However, whereas Uranus is unable to generate any additional heat beyond what it receives from the Sun, Neptune has found a way to reach Uranus temperature. An internal heat source, however, what exactly is it? If you want an easy explanation, just say it's leftover solar system heat from when the planets formed. It's known as the Kelvin-Helmholtz contraction because the heat condenses out of the early solar nebula. Joshua Tolfson, an astronomer at the University of California, Berkeley, explained that Neptune's extra heat source is primarily owing a gravitational contraction. Thermal energy rises out of the Earth as a result of the gravitational contraction of the planet's crust. As a result, it is unclear why Uranus lacks any kind of primary heating mechanism. Something must have slowed this process in Uranus, perhaps due to a collision in its early history that knocked the planet on its side, according to Tolfson. Because Neptune has an interior heat source, why does Uranus not? Neptune's strong winds are a mystery. To explain why Uranus and Neptune's winds don't match, Simon suggested that the winds are generated by a mix of internal heat and rotation because they have similar rotation rates. As Simon put it, it tells us something is different between them, partially internal heat or something else. Neptune's winds can reach 1,500 miles per hour, while Uranus's can reach 560 miles per hour. According to Tolfson, they're both extraordinarily fast and peak at speeds quicker than Jupiter. At 384 miles per hour, NASA estimates Jupiter's Great Red Spot. However, he agrees that these speeds can't be explained just by internal heat, because Uranus doesn't produce any additional heat. When it comes to figuring out what causes the winds we witness, we may learn a lot from learning about the planet's internal structure. Currently, NASA's Juno and Cassini probes are providing insight into the formation and depth of the planet's winds. These results are possible because of the high-quality gravitational data they've gathered, which allows for accurate models of the planet's internal structure to be developed. The highest levels of the ice giant's atmospheres are dominated by winds, according to computer simulations. Uranus and Neptune's rapid winds may be at least partially due to the latent heat release of condensation for things like water. Del Genio, too, is skeptical of the existing information. He goes on to say that we only look at one precise altitude when measuring the winds on Neptune. Other elevations may experience slower or faster breezes, Del Genio noted. It's important for us to know because we haven't seen any probes to the outer planets. Two extremes can be found in planets formed under the same circumstances. This helps us constrain theories of the development of these planets and provides insights into the overall formation of the solar system, according to Simon. Since they are so far from the Sun, they may be able to shed light on deeper circulation. Astronomers have gained a better understanding of Neptune's atmosphere because of this research. It adds to our knowledge of planetary atmospheres and helps us better comprehend our own Earth, said Hamill. Did you think all these mysteries and questions will later be discovered by the upcoming amazing telescopes? Kindly comment down below. Don't forget to like and subscribe to this channel and also hit the bell icon so that you can be notified when we release a new video. Thanks.